Welcome to another episode of Midterms in a Pod, brought to you by Study Sheep Club and the Addendum Club.
I am Houwen, and I am in Arts and Sciences.
I'm Linda, and I am also in Arts and Sciences.
I'm Laurence, and for some reason, I'm still in Honors Health Science.
Wow.
It's a weird flex, but yes, I've survived somehow. So it's rough. I questioned my existence sometimes. Yeah, I'm still in my program.
So we'll go over three broader topics that are coming up in the midterm: vectors, kinematics in 1D and 2D motions, and forces. I'm quite worried about what's going to come up in the midterm. How are you feeling?
Conceptually, reading the material is kind of okay, but when you get to the practice problems, it's a bit different, and you have to do big brains, so I'm also worried. But we'll get through this, and we have this whole podcast to film.
As just a quick disclaimer, please don't rely on this podcast for your full study. The methods that are thought might not align with what your teacher expects, so keep that in mind.
Oh, wait. Oh, this is part of the script. I thought it was the page above.
Yeah. No, it's totally fine to improvise a bit.
I didn't realize this was part of the script. Whoops. Okay, that makes much more sense now. All right.
Okay, anyway, guys, be a good student, study, and attend office hours if you need help, okay? We suggest you follow along with our podcast with your notes.
Okay, so Linda, are you ready for the exam? I'm definitely not. What topic do you struggle with the most?
Oh my god, I feel you, and I'm kind of worried about kinematics the most. But let's start with vectors.
Well, vectors give us all golden Sec 5 memories and PTSD, but I think it's a great place to start.
Yes.
Okay, so first and foremost, vectors have a magnitude and a direction. Another important thing to remember is that you always have to write your units in your answers. Please don't forget that.
And also be careful with your notation. Are you answering in unit vector form, or components, or in magnitude plus angle form? These are some pretty basic elements that you can lose marks on, so ask your teacher if you're not sure.
Yeah, although they probably won't answer you during the exam, so make sure to ask before. And I'm not very good with Fermi problems. Will they be on the exam?
I actually have no idea, so that's why, dear listeners, go ask your teachers. But basically, Fermi problems are something about estimating the magnitude of order, which is a 1 sig fig number. Let's say someone stopped you on the street and asked you how many piano tuners are there in Montreal.
So, Fermi problems. So, what were you guys? What is it about Fermi problems that are so interesting?
Just that I'm not very good with them.
Do we talk about piano tuners in Montreal?
Yep, we do.
Well, the answer to that is just enough to keep Anton Ye's piano working at all times. As long as we have enough piano tuners in Montreal to keep Anton functional, that's the right answer that we need to put.
Yes.
I wish I could write that in my exam.
Yes, please. Well, you never know what this wonderful world could bring us. Anyhow, for Fermi problems, we break them into smaller questions, such as how many people live in Montreal? What's the average family size? And also, how many times does a piano get tuned per year? And there's much more. Estimating these numbers and doing dimensional analysis will help us get closer to the answer, which could end up being something like 100? So yeah, remember, only 1 sig fig.
And of course, precision is always key. I'm not sure how you can be precise in a Fermi problem, but as long as you try to be precise, anything in life, it should be fine in the end.
Yeah, and we're also not sure if this is going to be on the exam, so yeah, be proactive and ask. But anyway, it's going to be hard to cover everything, so we're just going to shut up and dance the night away.
Oh wow, that was just a guitar that appeared out of the middle of nowhere.
Whoa, that's so cool.
That was really cool.
Place,
we gotta get through this. It's okay. Let's start with superposition.
So, superposition is just a term for when you're graphically adding or subtracting vectors together. The trick is to place the tip of the vector to the tail of the next one. And the resulting vector will start from the tail of the first vector all the way to the tip of the last vector.
If I can jump in right over here, this kind of sounds like ENM that you'll experience in your second year. So a bit of a spoiler alert.
Oh my god.
Vector addition, you'll be more prepared for ENM. Sorry if I'm scaring anybody prematurely, but just hope that brings some confidence in your studying for your mechanics midterm.
Yes. Yes, it's as simple as that. However, a much quicker way will be to add vector components together. For example, you can add all the ones in X and then add all the ones in Y, and there you have it, your resulting vector in components. And don't forget to add the I hat to identify the X components and the J hat for your Y components.
I'm also going to add that it's quite important to remember that when you're calculating vectors, you're calculating the magnitude. So no little arrows in the notation. That's something to be worth noting.
Yeah. And Linda, what's the other notation for vectors?
That's a good question. It's really just writing the magnitude and the angle. So take the angle that's less than 90 degrees.
True. I remember that. Okay. Just another few things that you shouldn't forget about. First, establish your coordinate system. Make a diagram if it helps you to visualize. Break down your vectors into components using unit vectors, if that's your preferred method. And also read the question carefully to find everything that's given to you. It's okay. You guys got this. I believe in all of you.
And I believe in you guys too.
In addition to believing and having all my faith in you guys that you do well, I also believe the Canadians will win the Stanley Cup this year. Hopefully they do. Likely they won't. But it's always good to believe in.
Yes.
And okay. Now on to kinematics. I get confused with the links between the position, velocity, and acceleration graphs.
That always confuses me. But what I understand is that the slope of the position curve is the value of velocity, and the slope of the velocity curve is the value of acceleration. And inversely, the acceleration graph's area under the curve corresponds to the velocity, and the area under the curve of the velocity function corresponds to the position.
Yep. And there can be two cases. So when the position curve is a straight line, whether horizontal or inclined, that means the velocity is constant. And in the velocity graph, we should only see a horizontal line. In the acceleration graph, it's a horizontal line at y equals 0.
And also, if you're able to master ENM as well.
Yay! Woohoo, okay. And also, when the position curve is curved like a parabola, the velocity is an inclined straight line. The acceleration would be constant, so a horizontal line anywhere but at 0.
Also, let's not mix up displacement and distance. Well, displacement is shortest distance from the starting point to the final position, and it's a vector, while distance is a scalar, taking into account that the total distance one has gone over.
I wish it wasn't distance that separated us, but only a displacement of 0, guys.
Linda, don't be so cringy. Next on our list is the difference between average velocity versus instantaneous velocity. So for the average velocity, it's the average between two times. So on the graph, it corresponds to the secant line. And instantaneous velocity is the velocity at a single point in time, which corresponds to the tangent line at that point. And it's the same principle for acceleration.
Just a quick note on the sign. Speeding up means velocity and acceleration have the same sign, and slowing down means velocity and acceleration have opposite sign. So in other words, one can be positive and one can be negative. We can use kinematics equations to solve problems, but only under constant acceleration. Remember that. A problem generally gives you 3 variables to work with so that you can find a 4th variable that you're looking for. And there's also one last variable that is generally not given. So if it's not given in the problem, it means you don't need it.
And also, sometimes if you have a bit of figuring out the variables, you can always try a substitution. If you substitute equations to simplify an equation, it could be a nice approach. And just to give an example of substitution, you can have it in everyday life. As a matter of fact, Omnivox should have the capacity to substitute your grades for better grades. So, sucks to say, but substitution is very relevant, not only in your exams, but in Omnivox in life as well.
I wish Omnivox could do that.
Me
But
too.
let's stop let's stop living in the 1D world and move on to the 2D world. So in 2D, there's two distinct motions in the X and the Y. So you must think of this when calculating problems.
Oh, yeah, I agree. For example, in freefall acceleration, we should only consider the motion in y-axis, although it still depends on your coordinate system, but generally it's the y-axis. This is one type of problem. So one object being dropped at a certain height versus another object thrown in a parabolic trajectory, but at the same height. So if they're at the same height, that means they will land at the same time because we're only looking at the acceleration in the y-axis. And of course, if they're from the same height, they'll land at the same time. Whether the sign will be positive or negative, it will depend on your Cartesian plane.
Yeah, I just thought of another type of problem. So if we have two cars racing each other that will intersect at one point, what we have to do is find the where, so the position / displacement, or when, delta t, and then we look for a kinematic equation that will help us find the answer, but always remember that the acceleration is constant.
And if ever you're stuck, just like we said before, substitute. Substitute everything, not only just your physics exam, but everything in your life. Just like how you substitute your BTS craze for better grades.
I'm not sure about that, but okay. Anyway, another one we've identified is when an object is thrown in a parabolic manner to two boats, and these two objects launched will reach the same height. That means that they will attain the two boats at the same time, because we only consider the acceleration in the y-axis, so the vertical motion. Similarly, if the object that's thrown doesn't reach the same height, then that means that we have to look for the one with the shortest height, because that means then that it's going to take less time, since we only, again, consider only the acceleration in vertical motion.
And of course, if ever you're stuck, sketching is always very helpful. The more you sketch, the more clear the situation is.
Okay, finally, we've got to a more complicated type of problem, which is projectile motion.
Wait, so just like when you throw a basketball? Sorry, I meant when you pass notes in class?
How about you explain it, Houwen?
Sorry, I'll my basketball in the classroom anecdotes myself. Time it's maybe a bit too premature to be broadcast on live.
Oh, okay. Well, projectile motion isn't too complicated. There's just a few things you need to keep in mind when doing a problem. So first of all, we always neglect air resistance to make our lives easier, and remember to clearly label your x and y components to not mix things up. And in the x motion, it's always constant velocity, and in the y motion, remember that acceleration in y is equal to 9.8 meters per second squared, and the sign of this depends on your coordinate system. If you establish downwards as negative, then it'll be negative, and if positive, then positive. And then another few pointers would be to establish a coordinate system, and always write your equations for Vy and Vx, and you can generally use delta t that was found in Vy equation to find a missing component in Vx or vice versa.
I agree with Houwen, and I think it's also really important to write down the constraints you have in your system. If you're throwing a ball in the air and you know it's going to come down at the exact same height, you can already write delta y is equal to 0, just to put constraints to simplify things. Constraints also apply in real life, just like how Anton Ye is, as we all know, a constant wedge in the piano.
Yeah, we agree. And actually, a more complicated problem would be those types of questions with two steps, where the final condition of the first is the initial of the second part. The trick is really to find the answer to the first one using kinematics equations, and consider that answer as the initial condition for the second part. It's helpful to treat them as two different problems.
A jiggle here, so I just wanted to play it.
Yeah. It's welcome.
Yes, very welcome. May the force be with you.
It's March 4th, not May 4th.
Don't kill my vibe.
You mean, let's kill this.
Love.
Actually, did you guys mean the song by Eric Clapton that goes, "Oh, love"? I can play on and on, but I feel like I'm slowly deviating. So I'll just revert back to talking like that.
I love Eric Clapton and also
Really?
Blackpink. Yeah. But you know what else I love? Forces.
You want to hear the sound of the force? I can pull up a force for you real quick. Yeah. What is this? That's the sound of the bus, the 165, zooming away from the bus stop. And picture this, 13-year-old Laurence every single day for 5 years in a row. Yeah, that was my high school life. Forces. Anyways, forces, where were we at?
Yeah, well, just same. Like 13 years old Linda running after the 121 every day after school because so many people take the same bus. It's impossible to find a seat there. But okay, so for now, you can remember the first two laws of Sir Newton. So Newton's second law is the net force depends on acceleration, where the equation F net equals mass times acceleration comes out from. Remember that here we only deal with constant forces, so a constant acceleration as well. And if we remove a push, then acceleration will equal to 0. And so the object will just move at constant velocity. And that's also what we call an object in its natural state.
Oh, really? Why is that?
Because when there's no force, there's no acceleration. So a constant velocity.
That's not exactly a pickup line, but I'm just off topic. Sorry about that.
Well, okay, let's get back to on topic. So remember Newton's first law? It's a law that states that if there is no net force on an object, then it's either moving at constant velocity or at rest. So that means acceleration is equal to 0.
Yeah, how do we use Newton's first law?
Well, now you know that A equals F net over our mass. So if F net equals 0, then A equals 0.
Whoa! Oh my god, that's so cool. But how about inertia and inertial reference frames? Those are a bit difficult to grasp personally.
Just remember to always draw your free body diagram as if you're an inertial observer. It's a common mistake to add forces to your diagram that don't exist. I might need to go over this with my teacher.
Same. But yeah, that's a big brain idea. But in the meantime, let me point out some other common errors, such as putting the given angle in the wrong place on your free body diagram, mistaking static friction for static friction max, and also you should look out for contextual clues. For example, if the question told us to determine the possible values, emphasis on the S after value, for the magnitude of the push force that allowed the lock to remain stationary, then we would know that they're expecting 2 values or more. So there could be 2 cases here. The first one is that static friction is less than maximum static friction. And the second case is that static friction equals max static friction. And also beware of inertial reference frames, like Linda just said.
Adding on to Houwen, I think it's also really key to always draw your reference system. Mm-hmm. If your X is pointing to the right and your Y pointing towards the top, it's really important to do that. And systems are also quite useful. How I managed not to get lost in Marianopolis or not get stuck at the carry interchange in rush hour while driving. Back to, I think, Linda, you wanted to get at how to best study for a mechanics midterm?
Mm-hmm. So I think the best way to study for Mech is really just to do practice problems. Try to explain the procedures to yourself or to others. But anyway, moving on. Here are some tactics. So always draw the scenario to help figure out what forces are in play and draw your free body diagram. That's very important because those really bring in your points in a problem. Remember that there's always a gravitational force, so Fg, generally pointing down. The object is on a surface, Then there's also a normal force, which is most of the time the opposite of Fg. But remember that what's important is that the normal force is perpendicular to the surface. If an object is moving on a plane or it's stuck, then there's probably static friction and kinetic friction.
Yeah, just to build on what Linda said about free body diagrams, also remember that parallel to the surface does not mean horizontal. So if you establish your coordinate system to have the x-axis parallel to the plane, then that's parallel, but it's not horizontal. So just be on the lookout for that. And another tip about free body diagrams is to break the force vectors into components. And also, for problems, you typically need to find the sum of forces for both the x and y components. And just another note, for every time, the only options for the sum of forces is either equal to 0 or equal to mass times acceleration. And last of all, double check that the signs of your forces match the FBD, the free body diagram, to not lose any more points.
Yep, exactly. And as mentioned before, don't solely rely on this podcast for your study, okay? Really, you have to study, and it's really important to practice with exercises. So this is, we already hit our end. We wish you really good luck with all your exams, and please check out other midterms in the pod.
Yeah, bye-bye.
All right, no worries about it. Oh, wait. Oh, this is from the script. I thought it was the page above.
No, it's totally fine to improvise a bit.
I didn't realize this was part of the script. Whoops.
Oh wait, am I supposed to laugh lightly? It's
Not exactly a pickup line either, but yeah, it's something along those lines of what was it again? Was it like an object is either at rest or in constant velocity if no force acts upon it? Something like that, if I remember correctly.
Right.
Like that.
I mean, not but fundamental to mechanics and passing NYA, I guess.
Bye-bye, guys. Good night.
Bye-bye, good night. Good luck. Yes, good luck.